Hi class, you guys just watched a video on the Doppler effect, and now I'm going to go a little bit more into detail on this. You're not going to have to turn anything in, you're just going to watch me explain this, and then I'll go ahead and I'll save these notes for you guys. You guys learned first semester about Doppler effect and sound, and you realized that if a sound is traveling towards you, the sound gets higher pitched, but if the sound is traveling away from you, it gets lower pitched. Well, sound and light are both waves, so therefore the Doppler effect also applies to light. And it turns out the colors that we see, red, orange, yellow, green, blue, indigo, violet, all those are different frequencies. And it turns out that the highest frequency is the violet, or just to make it easy, we call it the bluish colors are the highest frequency, and the lowest frequency color is red. Now, just like with the Doppler effect with sound, if the object comes towards you, it sounds higher pitched because the frequency goes up and the wavelength goes down. And it does the opposite when it's going away from you. Well, same with light. If the object happens to not be moving, if you and the object are sitting still, the frequency stays the same and the wavelength stays the same. And we would say that the sound of the light has no shift. It is the exact same for both people in that situation. But just like if a sound was going towards you, the frequency would go up if a light was going towards you, and the wavelength would decrease. Now here sound would become higher pitched, but for us we get a higher frequency of color, and the higher frequencies are the blue. So that means that the light would actually shift a little bit more towards the blue end. And it goes the opposite. If the light is going away from you, the frequency would decrease and the wavelength would get bigger, it would increase, and therefore we would say it has a red shift. So therefore this light might be looking like this, whereas this light would be more spread out. Now obviously in real life you never notice this because the speed of light is so fast, but if you're an astronomer and you're working with really expensive pieces of equipment, they can tell these tiny little changes in the shift of the color if an object's moving towards or away from us. And that relates exactly to star spectras, because astronomers can be looking at a star one day and they could see this, the original star, and then they can go back and look a week or a month later, and they would see that those spectral lines have been moved over. They've been shifted. They're the exact same pattern, just moved over. They all might have 5% higher or lower frequencies. And we can tell, because it's a color picture, that those spectral lines have been shifted towards the red. And what that means is that the light has become a smaller frequency, and if we look above, something that is red shifted means that it was moving away from you. So that means when astronomers are looking at this star, it is moving away from them. But also there could be times where they're looking at a star and the spectral lines are in the exact same spot, which means that it is not shifted, and relative to us it is stationary. It is not really moving further away or closer to Earth. And the last one would be something like this, where you look at a star and those spectral lines have been shifted over to the blue side. So that would be a blue shift. And if it's a higher frequency light, that means that the object is going towards us. Now to save some time, since we're not in class together, we can go ahead and skip this one. So moving on, so why do we care? Why is this important? It turns out that when astronomers look into the sky, they see that galaxies are almost always red shifted. And that means one thing, they are moving away, which is an easy thing to know. But also, if you look out in the sky and 999 out of 1,000 galaxies are moving away from us, that leads to pretty strong evidence that the universe is expanding. Now you've probably heard this before and you don't think twice about it, but Einstein was one of the smartest people to ever live, and he didn't even know the universe was expanding. He thought it was just sitting still. So Einstein was actually wrong, and it took that evidence, that looking at all our galaxies around us and seeing that they are all redshifted, to realize that the universe is actually expanding. Then as they started getting more and more data, they started making graphs, and they started making distance versus velocity graphs. And you can tell by this graph that as distance away from Earth increases, velocity increases. So what that means is they might have looked at the closest galaxy, which would be Andromeda, and they went over and they found its speed. And then they went to another galaxy further away, and they saw it had a higher speed. And then they went to a further away galaxy with their telescopes, and went even faster. And then they went and started looking at super far away galaxies, and they started measuring its speed. And they started seeing that as the distance away from our galaxy increased, the velocity increased, like every single time that happened. So what they started to figure out is that not only is our universe expanding, our universe is accelerating. So not only is it getting bigger and it's getting faster. So those are some things that people never would have known over 100 years ago. It wouldn't even be thought possible for this to be happening. Right now, just to give you a little extra information, they think there's something called dark energy that you don't have to know about, and they think that's the stuff that is speeding up our universe expansion. And today there are tons and tons of physicists and astronomers that are actually trying to study what it is and find out more information about it. That's about it. So to review really quickly, you guys need to know what a redshift and a blue shift is. You should be able to recognize it from star spectras like right there, and you should be able to know that the universe is expanding, and the evidence was the fact that most stars are redshifted. The ones that are not are the ones that are really close to each other, like Andromeda, and those are getting closer just because of gravity. And you should also know that as galaxies get further away from our galaxy, they are getting faster, and that means that the universe is not only getting bigger, but getting faster. That's about it. I'll go ahead and put this in our solar system and universe modules for you to look at later on. Thanks.